Continuous integration and continuous deployment are important practices related to GitOps. However, with GitOps, they may look a little bit different than you're accustomed to. A common pattern used by organizations as part of their DevOps practices is referred to as CIOps. Let's take a closer look at this pattern, then we'll compare how GitOps changes the approach. It starts when a change is made to the application source code in the repository. This triggers the build system. Next, the CI pipeline builds the software, executes tests against it, and then packages it into a container image that's stored within a container registry. Once the CI pipeline finishes its work, it triggers the CD pipeline, which has permissions to make calls directly against the Kubernetes API. This is where the security concern comes into play with this approach. We'll talk about that in a second. Once the cluster's state is updated in etcd, the cluster begins to materialize the desired state by pulling the image and deploying it across the nodes. Here's where you cross your fingers and hope everything goes well, because it's difficult to recover from a bad deployment when using this pattern. Okay, let's take a look back and see the downsides of this approach. First, there's little separation between CI and CD. They might even be the same tool. It's like you're forcing your CI tool to handle continuous delivery, something it wasn't meant to do. And that's where the problems start to creep in. The CI tool needs privileges to make calls directly against the Kubernetes Management API to perform the deployments. This approach is not secure. It violates a trust boundary and it allows an attacker to use a compromised pipeline to execute malicious code. It's also not very stable. If a deployment thrashes, this approach can leave the cluster in a bad state that we're not even aware of. These issues make CIOps a poor choice for managing multiple clusters or large clusters. So let's shift back to GitOps and talk about how it approaches automated pipelines. In the GitOps model, continuous integration and continuous delivery are decoupled into separate concerns. The CI pipeline is left intact. However, the CD pipeline is shifted inside the cluster, where an operator is responsible for automating deployment of changes into the cluster to ensure it matches the desired state found in Git. This alleviates the security concerns associated with the traditional push model that's used by CICD. It also provides recoverability because the cluster can easily be rebuilt. Let's dive back into an architecture diagram to get a visual of what's going on. GitOps largely leaves the CI pipeline intact, except for removing the trigger to the CD pipeline. Under GitOps, the sole responsibility of CI is to produce an artifact. In this case, it's a container image that's placed within our artifact repository. Here's where the operator in the cluster takes over. It monitors the desired state in Git for any changes, which are typically made to a separate environment repo using a pull request. So this could be something like an update to a Kubernetes deployment where we point to the new image created by the CI pipeline. Once a change is detected, it reads the specs for the Kubernetes objects and then uses the control plane to provide the new state of the cluster. This causes the cluster to pull the new image, and it deploys it across the worker nodes. So within this diagram, you see not only how GitOps adapts traditional CI/CD, but you get an entire overview of using GitOps as an operational model for a cloud-native application deployed on Kubernetes.